Okay, today we are going to be working, this is technically in the back of your book, but since we're not using books today, we're going to go ahead and work on it, reviewing this material this way. So I'm going to read it just to make sure you heard it. It says, a prime number has factors of itself and one only. We talked about that yesterday and trying to find out the definitions of all these words, and so that should be somewhere in the room. A composite number can be written as a product of its prime factors, called prime factorization. That's probably a lot more detailed than what we have in the room, but what it means is that a composite number basically is every other number that's not a prime number. It has more than a factor of one in itself. So we're going to start creating factor trees. The point of these factor trees is to either find the greatest common factor or to find the least common multiple. The greatest common factor would be to simplify fractions to lowest numbers, basically. The least common multiple is needed to add or subtract fractions. And you need that because the denominators must be the same. Push pause if you need time to copy that down. Otherwise, I'm going to keep moving forward. So step one, let's talk about how to make factor trees. And you probably have seen this before, but the side that is the factor tree is this side over here. I want you to notice that we are getting to prime numbers. Eventually, this is going to be the last prime number, but we start just by factoring the 20 into two numbers that you can multiply together. So this particular example chose 2 and 10. So that means that 10 then becomes 2 times 5. The way to write this is to make sure that you include all the prime numbers at the very bottom, or the roots of the tree. So therefore, the prime factorization of 20 comes from 2 times 5. So I'm going to fill in the blanks. True mathematicians will recognize that there are 2 2's, so that can be written as 2 squared times 5. We're going to find the GCF of 16 and 40. So they've went ahead and they've done your trees, but I'll prove it. 16 comes from 4 times 4. Neither of those are prime numbers. So it's going to become 2 times 2. You can then see that there are 4 2's at the very roots of our tree. 1, 2, 3, 4. So we will write that as 2 times 2 times 2 times 2. Oh, they already did. Sorry, that's a different question. Same thing got done for 40. So 40, if you do into 2 times 20, 20 gets split into 4 times 5. 4 gets split into 2 times 2. So the final of this one is 2 times 2 times 2 times 5. I am going to look back up at the top because we're looking for the greatest common factor. The greatest common factor is the numbers that they have in common only. You leave everything out. So they both have 2 2's. In the case of 16 and 20, I see 1, 2, 3 2's. I can see that 16 has an additional 2, but 40 doesn't have an additional 2 to go with it. So that means that my GCF is only 2 to the third, which is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So our GCF is F. Greatest common factor is what you're going to use in order to simplify your fractions. And prime factorization would be to make them have the same denominator. So let's do prime factorization. First, let's verify that they are correct. 6 is only split into 2 and 3. 2 and 3 are both prime numbers. 9 is split into 3 times 3, and those are also prime numbers. in order to find the least common multiple, that is every number that they have. So you can see, yes, I have a 2. 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 But as you can tell,
we'll see everybody there at 7:15.
we still need the extra numbers that both numbers have. So to do the least common multiple of this one, I've got a 2 and I don't have another 2, so I need that 2. They both have a 3 in common, so that's covered, and it's missing a 3. So therefore, it is 2 times 3 times 3. I used one of the 3s they have in common, then this is the leftovers. That's what I'm calling it. 2 times 3 is 6, times 3 is 18. I'm aware that I'm going fast. The greatest common factor and the least common multiple. I will tell you that I have to flip back to this paper too to make sure that it makes sense. There's a couple of tricks that I might share you, but it also might confuse you, so hopefully that helps. When I think of the greatest common factor, that's actually going to be smaller. So it seems weird to me, that's my connection, that the greatest ends up being a smaller number or the same size number. So I guess I should put smaller or equal to the two numbers that you're trying to put together. Whereas in complete opposite of that, the least common multiple is going to get bigger or stay the same. And that's because in order to get a least common multiple, one number has some in common with the other, but they both have leftovers that you still have to add on. So those are things that I do to help me remember. You'll want to keep this paper somewhere while you're doing the homework. Now we're going to do a couple of problems on the back, so ignore that.